In this episode, we're going to describe how current flows through a full circuit and the factors that affect the electrons flow, making circuits reading and understanding a lot more easier and fun, and finally fast. Continue the video and have fun. Now, taking this example to the practical part where we are going to learn equations, okay? So, through what we learned here in this example, we find the current flow, which is the Q over T. Q over T means the amount of negative charges that flows through the cross-sectional area in a time stamp. Later in this video we're going to describe what a time stamp is, okay? So we're going to describe also that volt equals the current multiplied by the resistance. Now let's take this further on our example. Okay, we have a neutral element in this cross-sectional area. Let's multiply all the cross-sectional areas with all the neutral elements. It's called the wire resistance. You know, it's not gonna be called the resistance to link. No, it's gonna be called the wire resistance. This wire resistance is gonna be, for example, 5 ohms. These 5 ohms is the factor where we say there is a number of neutral elements that blocks the electrons flow. Okay, we have the resistance here. It's consisted of the rho, the internal resistivity element of the material, multiplied by the length of the wire, which means the number, all the numbers of the cross-sectional areas through the wire or the material, you know, divided by the area. Okay, divided by the area. It's a lot more easier to understand that volt equals the current multiplied by resistance. So when resistance gets high, you know, it's possibly known that the current flow is less. Let's take this practical. Now imagine if the neutral elements gets a higher number, which means instead of 3 there's, you know, maybe 10 neutral elements. You're gonna find here that in sector 2 the negative charges are going to be a lot more or less. Maybe they're gonna reach 2 electrons or something. So in this sector 2 you're gonna find that the differentiation of the electrons before and after sector 1 and sector 2 decreased, which means the electrons flow decreased, which means the current flow dramatically decreased due to the resistance increase. That's in one case where the voltage is constant, for example 5 volts, and we're going to describe this further through the rest of the video.